Greetings 242. So in this first video we're going to be talking about what are called antiderivatives. And an antiderivative is just a fancy word for what we're going to be able to do in the process of reversing the derivative process, reversing the differentiation process, right? So this process that reverses the process of differentiation is called antidifferentiation. So it just takes a function and then asks what function that thing is a derivative of, right? So we have some specific notation for this, and this is a definition that your textbook uses, but we say the following. We say that we say something like capital F is an antiderivative of little f if we know the following relationship is true. If we take the derivative of capital F and we get little f, right? So notice that you take the derivative of capital F and you get little f, right? What that means is if you started with little f here, it is the result of applying the derivative on capital F. So if we started with little f, the antiderivative of little f would be capital F here, right? So, and that's why we have capital F is an antiderivative of little f here, right? So let's think about an example. Right? So let's see if we can find an antiderivative. Let's find an antiderivative of, let's try something like, how about this function? What about, let's start with something a little simple. How about 3x squared? Right? What if we start with this function 3x squared and we want to find an antiderivative of this thing? Well, remember, an antiderivative, we're using capital F notation for that now. So let's see. If we had 3x squared, and we know that that's our function little f, right? What is the original starting function capital F that we took the derivative of to get little f? Well, what is the function whose derivative is 3x squared? And you might know this one just by looking at it or by thinking about maybe the power rule, right? If we think about the function x to the third, right? If we were to take the derivative of x to the third, we would get 3x squared, right? So what that means is that x to the third is an antiderivative of 3x squared, right? So capital F is an antiderivative of little f, right? So there's one possibility. Are there any others is a good question. Well, let's think about this a little bit carefully for a second. What about something like this? What if we had, well, we have x to the third, but isn't it true that the derivative of this function, x to the third plus 2, is also 3x squared? So what that means then is that we have two possible answers here. Right? The derivative of x to the third plus 2 is 3x squared because of the power rule, and the derivative of x to the third is also 3x squared because of the power rule. Well, is it possible to have two antiderivatives? Well, yes it is, and in fact it's possible to have infinitely many antiderivatives because notice I could have put any number here I liked. I could have put any number besides 2 here. I could have changed this to anything. Over here it's really, there's like a 0 here, right? Plus 0 here. So I could have put any real number I want to here. The derivative of that term right there will always be 0, which means that the derivative of anything x to the third plus a number is going to be 3x squared. So really, if we wanted to, we could say that an antiderivative of 3x squared would be anything of the form x to the third plus some sort of constant, some sort of c, some real number. So we can say c is a real number. And I can't write the word number for some reason. So c is a real number, right? Okay, so anything of this form, x to the third plus c, where c is just some sort of real number, will be an antiderivative of 3x squared, because when you take the derivative of this thing, the derivative of c, which is a real number, is 0, and the derivative of x to the third is 3x squared. Okay, this is what's called a family of antiderivatives because it is inclusive. It includes lots of different possible functions, right? There's lots of different options here for what capital F could be, and so it's a family of functions, a family of antiderivatives. So we'll finish with that example for right now, and we'll pick up another example in the next short video when we work on finding some more antiderivatives.